straightforward. Yeah. Yeah. So you integrate. So area bounded by the curve and the line. So basically you have this part, and you also have this part, right? This is part 1, this is part 2. Why I split it into part 1 and part 2? The reason is part 1 is above the x-axis, which is the positive region of y.
Okay.
And this part is the negative region. Okay?
Okay.
So when it comes to area, do you have negative value for area?
No.
No, yeah. You shouldn't have. So therefore, right, this is the positive region, this is the negative region. If you just take 1 plus 2, right, you know what's going to happen? This is positive, this is negative, right? If you go and add up, this negative will actually cancel some of the 1.
Yeah.
Right? So that's why you cannot just do the integrations from P to Q and then just do the curve which is negative cosine half x to the reciprocal x. You cannot do this straight away, because if you do this, you're going to end up with a negative answer for this region 2, and you're going to end up with a positive region 1, and the negative and the plus, they will somehow make it less, right? So what's the right way to do this question in order to have both plus plus? That means you need to see this as a plus. You also need to see the 2 as plus. You don't want to see the 2 as negative, because if the region 2 is negative, it will cancel some of the 1, right?
Yeah.
Which is right. So how do you get 1 is plus, 2 is also plus? Okay?
Okay.
Okay? How?
Magic.
Not so much. Okay, so you should, okay, let's assume that P is pi, a negative pi, because it's the negative region. Okay, so this is pi, because it makes life easier for me to do. Okay, so now let's do 1 by 1. How do you get 1? How do you get the region 1 first?
From the same P, Q, and then the...
So this is pi, negative pi, so this is pi.
Yeah.
Okay, there are two ways, right? When you find area under the curve, right, remember area under the curve. Area under the curve. What's the meaning of area under the curve? That means area under the curve. So,
oh, it's the whole thing, not just...
So if you want to find the area under the curve, I think you can find the rectangle first. Then you minus off the 2 triangle. Okay? Okay?
Okay.
So in order to find the area of, this one is not triangle because this is a curved line. This is not a straight line. So in order to find the area under the curve of this thing, so you need to find out what's this value also. This is your lower limit, this is the upper limit, which is pi. So you integrate, so this is the, let's say I call it L, so you integrate L to pi, and then this is the function. You will get this small one, and then you times the 2, you will get the 2 blue one, right?
I thought...
And then you just use the entire rectangle minus this, you will get the 1. Tell me what you thought. Tell me what you thought.
It's like, isn't it like also like...
Remember area under the curve, yeah?
Q to L, so... Oh wait, okay, I understand.
It's area under the curve.
Yeah,
That's why
so
I keep emphasizing area under the curve.
Okay, I got it.
Okay? So you can only do area under the curve. That's why I use this technique to find 1. Right? Region 1. So region 2. Region 2, area under the curve. That means area under the curve can be, under the curve means this part, you know.
Yeah.
Right?
Yes.
But now you need to find this. It's above the curve. How? So since I call this the lower limit,
We call it the upper limit.
I call this maybe the lower and lower. So it's lower 1, lower 2. Okay?
Okay.
You need to flip it over. How do you flip this thing over? By triggering which function? Negative, flip to positive. Which one you
Oh,
use?
so that means differentiation
No. How do you get negative into positive?
by adding negative.
No. Yeah, no. Yeah, by adding negative, but which function? There is a function that you can flip negative to positive. And we just talked about it at the beginning of the lesson. Modulus.
Of course. Oh yeah, modulus.
So you integrate from L1, I'm talking about 2, L1 to L2, right? This one, right?
Yeah.
Okay. So from where to where? From here to here, lah. So negative cosine half x dx. So you modulus it.
Okay.
So basically you modulus this. You modulus the function. Once you modulus the function, right, it will the negative, all the negative will go up, right? So once you go up, then you just from L1 to L2, just integrate under the curve. You understand me or not?
Yeah. So you still need to minus.
So you have this, right? But this one is the negative one. I mean, this is the negative part. So you don't want to get area. You don't want to have a negative area. So what you need to do? So you need to modulus the function, modulus whatever you have here, right? So modulus whatever you have here. So that's why you modulus this, and then you integrate from this point to this point. So this is the modulus, right? So area under the curve. Is it area under the curve now? Yes. Right? Over here is not area under the curve. Over here is area above the curve. Right?
Yeah.
Yeah.
So
Okay. So that's
the upper
how you get
limit
2.
and the lower limit.
L1 and L2.
I thought the upper limit is like.
Yeah.
So you just.
Then this is the L2. This is the L1. So this is L2. L1. This is L2. So you just integrate this, then you get 2. And then that's how you get 1. Then after that you just add these 2. They are both positive. Then you get the area bounded by this. Understand? Understand or not?
I'm still confused about the
Which
lower
one?
limit and upper limit.
There is no confusion about the lower limit and upper limit. Which part? For the 1 or for the 2?
The 1 or N2 or something.
Never mind, 2. Ask yourself, area under the curve is here one, right?
Yeah.
From where to where? From this point to this point. That's why I take L1 and L2.
Okay. Okay. Then for the first one.
For the first one is very simple. For the first one is you want to get the one triangle. I mean, this one looks like a triangle. Then you just times 2, right?
Yeah.
So it's from basically where you want to integrate from, and then end where. I want to integrate from this point to this point. So that's why I pick what L, in this case L2, to pi.
Okay.
No, the thing is, now you have this. I want to find the area under this curve. Where you start?
From
where? A, B, C. From where?
A to C.
Yes. So this is the lower limit. Basically, you want to integrate from from A is below to C above.
Okay.
That's why it's L2 to pi in this case. L2 is here, pi is here. Okay, so that's how you get this.